Welcome to another edition of the Subseasonal Forecast Contest. Today is August 25th, we have, we're going to, in terms of today's agenda, propose we start with our sort of typical attribution. We'll look back at the past week and past really summer in total, and then we'll talk about the current forecast. And if anyone wants to talk about any kind of research items, I know there's been a few different research topics over the last couple of weeks. We hopefully maybe we'll have some time for that, especially since it looks like we've got Dr. Roundy online, and Professor Roundy always has some interesting research topics to discuss. Other than those agenda items, is there anything in particular anyone wants to cover today? No? All right, well, if you think of something that we didn't just talk about, just let me know. All right, so let's start with the most recent verification here. So I believe that was from the forecast made up top here, August 4th, verifying just a couple days ago, August 19th to the 23rd. The verification was at about 54 CDDs. You can see at the bottom here. Just to benchmark that, the 30-year is about 48.4. And the 10-year, where's my 10-year? 10-year is 52. So we were a little bit above the 10-year and 30-year. So after that, we had a couple of weeks there where we saw things cool down a little bit, but obviously the last couple of weeks here, the forecasts have rebounded pretty warmly. In terms of verification, so the process we normally go through, especially for some of the folks who are here, we'll just talk a little bit about the performance. We'll pull up Dynacast here and also look at the how, spatially, how the forecasts verify. And we'll also pull up Maxar's 16 to 20-day report from August 4th, just to kind of get a glimpse of what we were all thinking or seeing back then, or at least what Maxar and some of the information there was showing. Yeah, in terms of our leaderboard here, in terms of CRPS, Matt Lanza was led the board here, had the highest score. You can see he was pretty close in terms of his center line number, and he had a relatively low spread, 4.5. So the combination of a pretty good center line and a pretty low spread got him to the top. The 10-year, which has been pretty good. This is something that Nat Johnson, I think Nat, you're on the line here too.
Yeah.
Yeah, Nat had some nice performance charts last week. Some of you folks may have seen it. We did post it on YouTube or whatnot. But the 10-year has been difficult to beat, is the long story short, especially in the summertime. That's probably not a surprise to any folks who have been doing this for a while. But obviously with the warming summers and stuff like that, the 10-year norm is tough to beat. So that did pretty well also. And then Nick, one of our student members from Rutgers, I believe. I don't think he's on the line, but he's been doing pretty well so far. He was near the top. I guess looking near the bottom of things, the ECMWF had a tough time of it. Looks like the ECMWF was just too warm. And we've seen that a couple times this summer. I know. I know, I don't think it wasn't a discussion from last week, but folks who have been on these calls for most of the summer will recall that some of what I'm saying is obviously a little bit qualitative, using some liberties here. But I know there was a period here where we had a discussion about the fact that the ECMWF for at least 2 or 3 weeks in a row was way too warm. And I know we made some anecdotal points about the fact that it seemed like, once the EC got to, maybe was okay when the pattern was sort of locked in, but it didn't respond well to, when things cooled off a little bit, or so. It just seemed too warm in general and maybe locked in general. So interesting to see that with the EC. And then just a quick reminder for folks who haven't seen these, the persistence metrics, we now are including those in the weekly tables. So these are the weekly tables. And, what does it mean when it says like persistence 15-day? So basically it's basically what it sounds like. It's looking at the past 15 days of history, observation up through yesterday. So what was yesterday? August 24th. So August 24th, and then going back 15 days and saying, all right, what was the anomaly? What was the, in this case, CDD anomaly during that period? And then whatever that standardized anomaly was, to apply that to the 16 to 20. The idea being that, you know, the rule of thumb by some folks in the market has always been, or has been that, you know, persistence might be a useful tool. And so anyway, we put it in there, and that's why we put it in there. All right, I'm going to go over and look at the Dynacast here for August 19th, 23rd. Folks should also feel free to jump in here at any point. But here's the, in case you're wondering about the spatial pattern here, here's what it looked like for August 19th to the 23rd. I just want to make sure this is right. Yeah, so we had, these are the numbers, and we just talked about the numbers, about 54 CDDs, the 10-year 52, the 30-year 48, and then I'll switch back to the pattern. This is interesting in the sense that if you had asked me what number this would be, what CDD number would correspond to this pattern, I probably would have given you a lower number because, you know, you're really putting quite a dent in some key areas like Texas in terms of, you know, that produce some pretty good CDDs this time of year, pretty good population areas, Dallas, whatnot. But I guess that was overcome by the fact that, you know, we had some pretty extreme heat in, you know, California and Phoenix and areas like that. And even into the mid-Atlantic and Northeast, some key population centers, New York, Philadelphia, et cetera, were pretty hot there too.
And the colors don't necessarily, I'm sorry to interrupt, but you know, the cool area, except for a little tiny spot there in Oklahoma, it's in the -3 to -5 range. But then you're looking at like Los Angeles, Las Vegas, they're looking at least +5 to over +8. So the warm is larger than the cold, even though, and just looking at the colors, it may not be obvious, but.
Yeah, I think that's right. I think that's what fooled me at first. Yeah, because, you know, it's funny. I guess, you know, this is worth spending a second on too, because, you know, it does good to show too that, you know, it's maybe even more so in the summer, you know, you know, this pattern, almost like a positive PNA-ish pattern, at least in the United States, you know, again, that, you know, you could still get a pretty warm outcome, right? Even putting the trough in basically putting the trough in the Southeast United States, you know, the coolest anomalies, and you still end up with a CDD output that's above the 10-year, you know, above the 10-year. I mean, look, I mean, you put the trough in exactly the right place for a cool. So in other words, maybe, you know, you look at this and say, well, I would expect a cool pattern, but this starts, you know, sometimes we talk about how things like, you know, well, the NAO doesn't have a perfect correlation with HDDs or CDDs. You know, just because NAO is negative or positive doesn't, even in the winter, it doesn't guarantee. I mean, this is kind of an example of that, where you might have the pattern that more times than not would be associated with CDDs that are near or below average, right? But in this case, it found a way, like Dr. Decker was mentioning, the fact that the intensity was so great in the West, and the fact that it kind of got cut off, right? It got cut off. And, you know, forecasting a cutoff like this with the low trough in Canada and in the other piece in the Southeast, obviously that's difficult to do 16 to 20 days out, but the devil's in the details, and that still resulted in a pattern that was, you know, again, above the 10 and 30 year. Anyone else have any thoughts? I'm going to pull up the 16 to 20 while we're talking, but just jump in here. That's the wrong one. What do we say? August 4th, right? I think it was the mark date. Let's pull that up and see what our friends at Maxar were saying here. Okay, so this is the Maxar report up top left. You know, this is their spatial pattern. So, yeah, and even here's the EC down here, you know, you can see my pointer, and then the CFS. And I don't know how you want to grade this. It's always hard to grade these subjectively. But I think it's fair to say with the Maxar, obviously there were a lot more cool anomalies, across Dallas and Texas. And the heat in the Southwest, they definitely got the pattern there, but as Dr. Decker pointed out, the intensity was pretty extreme. And then you could see that, we had the cold pocket in Southeast Canada, right? So I'll just flip back. Where was I? Over here? Yeah, over here. So there's the realization, right? And we had the kind of cool anomalies there in Quebec. And then here's the forecast and even the EC. So, not exactly a great resounding, spatial presentation, I think, from the EC there. Let's take a quick look at what they were saying back then. See if there's anything interesting real quick. Pattern is influenced by the GWO. Some folks on the line may know, and that's related to the atmosphere angular momentum. AM remains negative, model trends, negative WPO, negative PNA. Of course, that didn't really happen. Yeah, but this is a case. They certainly got the numbers were in the ballpark, right? They forecasted 58. What do we say? I guess it verified 54. We said. So the forecast was certainly was better than the 30-year. I think slightly worse than the 10-year. So it's kind of a case where the CDDs worked out okay, but from a spatial pattern, maybe those scores wouldn't have been as high. So any other thoughts on this particular week? Otherwise, I'm gonna look back and just see how things are shaping out for the summer as a whole.
I just say, I thought it was pretty impressive, given that the overall performance seems to be better than a lot of the individual guidance, the EC, CFS, the MJO. Just they're pretty good.
Yeah, that's a good point. I mean, from a forecaster perspective here, most of the forecasts did really well. Actually, that's a good segue into summer skill, because I think you'll see, one of the things we do, for better or worse, maybe it's worse, I don't know, but here's the performance season to date, cooling season to date. So this goes back to forecasts that were made starting on May 1st. And, what you see is the CRPS is the second column, and most of the forecasts are better than the 30-year. Now, again, maybe you argue that the 30 years too easy of a benchmark. I don't know if that's the right word, but again, the fact that the summers have been, arguably pretty consistently warmer than the 30-year. So it's, we've talked about maybe maybe the benchmark in the summer should be the 10-year. Maybe that's a more true benchmark for the summer. Can you beat the 10-year? You can see the 10-year here has been the 10-year and the consensus have been some of the best performers in terms of some of the best human performers here. Actually, we've got a couple of the callers on the line, Professor Decker and Professor Roundy. Wow, neck and neck there, right? Mm-hmm. Although Professor Roundy here looks to be the highest performer who's submitted forecasts each time, 14 forecasts there. So.
I'd like to see how you do this CRPS score. It seems to be benchmarked not against the verification, but against the climatology.
That's right. That's right. It's benchmarked to the 30-year normal.
Yeah, it seems like if you want to minimize error, you should bench it against the verification.
Yeah, that'd be something we could try.
Well, that's showing what your actual error is.
Yeah, right.
So like I didn't have any error in the last forecast, right on the integer money.
Right.
But I got a worse score.
On the current forecast here, the most recent verification. Let's take a look.
I think the score is taking, so you're forecasting, we're all forecasting a probability distribution, and climatology is also a probability distribution. And so for a given verification, we have there's a probability of that particular verification occurring as implied by all of our forecasts.
Right. So your error is compared against the error of climatology. But the benchmark temperature, the benchmark prediction that you're working against isn't. The zero error is the one that's right on verification.
Right, but this oh, go ahead.
Well, you're not necessarily going to get zero error if if your forecast was a mean of 54.2 and your spread was 30.
Right, of course, but
CRPS.
Of course, but
Yeah.
but your zero, look at where your zero is. Your zero is on the 30-year normal, not on verification.
Right. Yeah. Yep. Yeah, because I guess the CRPS is trying to answer the question, are you adding skill beyond just forecasting the 30-year normal? Right, the verification is not known when you make your forecast. So is it.
Right, but I mean, whether you're right or wrong is determined by the verification.
Yes. Over the long term. I mean, right, a CRPS, any individual, you really shouldn't look at just one forecast because any probabilistic forecast, one verification doesn't tell you a whole lot.
Yes, of course.
Looking over the entire summer, I guess, is more informative.
Yeah, but each forecast should be verified against its verification.
I guess we'll just see what the math.
Yeah, you look at the equation. There's a definition for the score.
Yeah.
Yeah, maybe we can talk about that, Paul, a little bit more offline. I'm happy. One of the things we always try to do here, you can see obviously we have several performance metrics here: the bias, directionally correct, performance against consensus. So always open to trying new metrics that, at the end of the day, right, you get to. A lot of this is geared to industry too, right? So we're always trying to find new metrics that are, at the end of the day, going to provide meaningful information. So I think if that's something that you think would be helpful, we can look at it, adding that metric. Yeah, for sure. And it's true, like just thinking about the industry perspective, directionally correct, I think, is a very useful metric. But I know also people will say, are you on the right side of normal, and how do you compare to other folks, right? You can compare this, right? But I know what folks in industry will also say is, yeah, it's good that, you're directionally correct, but, maybe they'll say it's because you're conservative. And they're going to say, well, we want to make sure that when the big calls happen, when the big events happen, that you do better in those, because those are the ones that are most important. And I only bring this up because it's an example of where there's, in a lot of cases, there's just not one metric, one size fits all, right? And so there might be a better metric that identifies those, those highly anomalous events or something like that. Okay. Let's say but just okay. So back to looking at the summer as a whole. Any other thoughts in terms of summer performance here before we switch gears? And I guess any thoughts, again, especially since we have Dr. Decker and Professor Roundy here. I look at the CFS. Obviously, you can see the bias here is -10. The ECMWF doesn't have a bias, much of a bias anyway, to speak of. But the performance is certainly not near the top. There's a number of, human forecast and, other forecasts. Most forecasts, in fact, I just sorted it by the second column. Most of these forecasts here have done, better. Any thoughts here in terms of the CFS? I mean, I guess the question is, should we even? And Nat talked a little bit about this last week. That maybe like a bias-corrected version of the CFS is useful. But any other thoughts in terms of why these models, or in particular the CFS, perform so poorly here in the summer? Is it like tropical forcing related? Is it parameterization? Is it just the fact that you know, we are looking at the surface, like 2-meter temperature, and the fact that, you know, it's at the 2-meter level, it's just, it doesn't, you know, it just does not resolve 2-meter temperature well?
The model has very large biases. And I'll never forget when Nick Schiraldi, one of my former graduate students, put together for his thesis a assessment of the seasonal cycle of bias in the CFS and ECMWF and Bureau of Meteorology, Australian Bureau of Meteorology climate models. And just the size of the bias relative to a fraction of seasonal variability. It's sometimes as much as 40–50%. So much so that it was collapsing the subtropical jet stream during the winter over the North Pacific.
Yeah.
It's just really bad. I mean, all these models are really bad when you think about the seasonal climatology of bias in a quantity like geopotential height. There's a lot of factors that cause the error. I mean, one of them is just simply the ozone parameterization in the upper troposphere. The radiative parameterization is a warming. Cooling the upper troposphere in a big way, and so it realigns the jet streams as a consequence. It's hard to not have big errors long haul if you have such large biases.
Paul, let me ask you, since you're talking about it, do you find value when you're making a forecast, you know, a medium range forecast? Do you look at the CFS? And if you do look at the CFS, do you look at it because it's, how do you utilize it as part of your forecast process?
Well, the main reason I sometimes use the CFS is that it has such a long and detailed climatology. I mean, the climatology isn't uniform because there are periods of time when observations incorporated behave differently than other periods of time. And so the result is some systematic biases that vary over its whole climatology. But at least we know what they are. And with so many forecasts made so often, that climatology is more useful in terms of trying to understand the behavior of the bias and how it can evolve with different base dates and so forth than with the ECMWF, which produces a better overall model. It still has a long climatology, but not nearly as many forecasts available. And so you don't have as deep of an understanding of the variance from one forecast run to the next as you would have if they were run 4 times a day instead of, say, twice a week.
Right.
So the benefit for the CFS is that we know its climatology. We can have a pretty high confidence in how it varies over time and in different conditions.
Yeah.
I think I thought maybe a good example of this point is I was looking at the Maxar report from, I guess, yesterday. Looking at the EC and the CFS, the maps they show very similar. I mean, you'd think you know, they're going to show very similar values, but the maps, they say the CFS they show relative to the 1999 to 2010 model climatology. Then when you look at the values they show at the bottom of the report, you know, the CFS is like 10 lower. So so I guess that must not be based on the model climatology, but
they've truncated the model climatology because the CFS has a breaking point in that climatology across 1998.
Right.
Something in the ocean model at that point that changed.
But even if you're relative to the 12-year climatology, at least in this case, you can see, I mean, the values seem more in line with the EC than just use.
In this case,
Oh.
there was a substantial subseasonal tropical forcing signal that was moving in the direction of this outcome that both models seemed to pick up on. It was really totally consistent with some of my just MJO-based OLR statistics, which were moving in the same direction. And to see both models concurring, it was, and also showing the convection in the right place, was suggestive that they were keying in on the same signal, and so that there was a lot of consistency leading to that outcome.
And you're referring that, you know, when initialized, we were somewhere out here in phase 4 on August 4th, but then we saw this kind of quick hook over to phases 8 and 1 during this period, clarification period.
Yeah, the two different models had a different expression in RMM2, but a similar expression in RMM1. So I was remembering looking at the GEFS at the same time as well, and comparing that with ECMWF, looking out days 10 to 15, and showing the just the change from the right side to the left side that all the models were basically agreeing on, but the variance in RMM2 wasn't so agreed upon. But there was a pretty high level of confidence that there was going to be movement toward the left side of this figure.
Right. Right. Okay. By the way, this is a little bit confusing to me too. It's easy to miss this point, the fact that these normals are a little bit different, but I guess that's a separate topic. Okay. Any other thoughts here? Otherwise, I guess we can switch gears and talk about today's forecast. We can't avoid it, right? It's always more fun to talk about what's happened, and it's scary to talk about what might happen, because then you're on the hook, right? All right, but we'll switch gears here. So it's today's August 25th, right? All right, so we're looking out to September 9th, 13th. We're still forecasting CDDs. I'll just sort this by the mean forecast here. So it looks like our ranges, on the warmer side, well, some of these persistence factors, and it's been a hot summer, so these persistence numbers are relatively hot, size 49 CDDs. On the lower end, guys, I think that's right though, almost 21 CDDs from the CFS. You know, keep in mind that -10 cold bias this summer. And then just, you know, kind of looking at the benchmark normals, the 10 years 39, and the 30-year is 32. So 32 and 39 are sort of your goalpost, I guess. And then the end lines are 49 and 21. All right, so would definitely want to turn it over to folks here. I just, you know, for a couple of the students who are on the line, like I think Sean and Philip, just reminder, let's try to go through our process here. Since we have Paul on the line, you can you know, maybe Paul can be sort of this. Actually, Paul, I don't know, you're not sure if you're aware. What we try to do is ask, especially our student forecasters, try to communicate their forecast in a quick, like 2-minute drill, like with as if they're communicating their forecast to an end user, a client. So you got to get out the most important information. And of course, for our client, in this case, it might be you, if you're on the receiving end, say a Philip or something, you know, you're allowed to ask those tough questions, put your client hat on, ask those difficult, hard questions that you might want to know if you're making important decisions based on this forecast. Okay, so with that, and maybe we'll kind of go back and forth between a couple of the students who are online and then a couple of the professors who are online. But how about we kick it off with one of our students who would like to kick things off? And I'd ask, if possible, please share your screen. If you like, you can share your video too.
I can go first.
All right, that's Michael. All right, I'm going to stop sharing so that you can share, Michael. And again, why don't you present this forecast to Professor Roundy, if you don't mind. Professor Roundy this month.
It's telling me host disabled participant screen sharing.
Oh yeah, they know about you. No, I'm just kidding. What's your working?
Okay, there we go. This looks good. All right. What is this? There we go. All right, can everyone see it okay?
Yep.
All right. So good morning, Professor Roundy. Forecast for today is for 38.2 CDDs. Started off with a base of 37.4, based off my Euro 10-year blend. Then I increased that by 0.3 CDDs based off the CPC forecast, which shows mostly warmth across the CONUS, mainly centered in what appears to be the southwest. But area of note to watch is this large area of cool in the central Midwest near Chicago and a couple other southern areas. So that could lower the values a little bit, but I don't think it'll be too much of an impact, especially with all the warmth in the west and some probable continued warmth in the I-95 corridor. That should help moderate any coolness in the Chicago demand region. Moving on to the teleconnections, looking at a positive PNA, although it's a bit, the forecast is a bit tough in the 15-day range, but especially considering it, there's no trend to look for here. AO neutral, again, not a big factor at this time of year anyway. And NAO I treat it as negative, even though it is also a bit spread out towards the 15-day period as well. And I think I forgot to mention spread was 5.8, so normal confidence spread. Any questions, complaints, comments, concerns?
It's interesting. Good arguments. So what would you expect an NAO signal this time of year to, how would it relate to Eastern US population temperatures, for example?
I believe a negative NAO around this time of year is still a warmer signal, but towards I think late September, it should start switching back over to a cooler signal, if I'm not mistaken.
I think that's consistent with some of what I've seen recently as well.
Cool. Any other questions for Michael? No? Cool. Professor Roundy, any other questions for Michael on your end?
No.
Okay. All right. So, how about who would like to go next? Professor Roundy or Professor Decker?
I guess I could go since I'm always simple. So as always, I'm just trying to turn the CPC forecast into some numbers, and we have a change in the CPC forecast compared to the last many weeks. There's actually a substantial region of below normal temperatures in the forecast. It actually looks somewhat similar to the current verification. I don't know if you have that tab available, or I can.
Oh, yeah.
I have it on a different screen, so I can't share it too quickly. I'd have to dig it up myself. But it's showing that area of below normal temperatures forecasted. There we go. Pretty close to where it is in the current verification. And you can see the above normal highest probabilities are right over the west, where it's been super hot lately. So it's sort of like a persistence forecast in a way. It's not showing that cooling over Maine, but otherwise it's pretty similar to what's going on right now. So I guess I should have paid more attention to the actual verification for the most recent period. I didn't look at that. But I did assume that the above normal is outweighing the below normal. There's a larger area and higher probabilities. But I did temper my above normal forecast. In the past few weeks, I've been going a half to 2/3 of a sigma above normal when the entire country was blanketed in orange. And this time I only went about 20%, 0.2 sigma above the 30-year normal based on that forecast. And I increased my uncertainty a little bit as well. You can see 7 as opposed to climatology is less than 6. Just to indicate, if that area of below normal ends up being a little larger, there are also areas like Chicago, Atlanta, Dallas that are right at the fringe of that area. So there could be some highly populated areas swinging one way or another, affecting the overall score for the cooling degree days. So that's how I came up with my forecast.
So I can share mine.
Yeah, go ahead. Here, I'll stop sharing. If you'd like to share your screen.
Okay, here we go. I'll just give it the whole desktop. So in making this forecast, I was looking at two general metrics. The first is what my subseasonal component of the signal from tropical forcing was doing at the time. And what we're seeing leading into that period of time, but then fading across that period, is a tendency for the tropical forcing to be associated with a ridge-trough-ridge pattern over North America, with this trough intrusion somewhere in the Midwest. As you move through the period, the eastern part of it, at least in these statistics, the eastern ridge area and the whole thing slides a little bit to the east, and so there's more of a trough moving into the northeast. But at the same time, there's this ridge in the southwest that kind of extends. Now, this isn't a particularly strong signal, so I'm weighting the pattern early in the period more than the pattern later in the period, because confidence in the outcome goes down with the amplitude and the length of time looking out. Keep in mind also, I was looking at this when it was in the 20 to 25 day range instead of right now, but it's looking pretty consistent through that period, which is also a good sign. And then looking at the ECMWF, these are the from this Monday forecast instead of the Thursday, but again, there's been this consistency overall, a lot of subseasonal contribution to the 5-day mean as opposed to synoptic expression that way. There's a bit of consistency here in what I was describing, at least between here and here, in between my statistics and the model, showing a pattern of a bit of an eastward slide between these pentads, but still the same general signature of ridge, trough, ridge. And so this was basically the grounding for my forecast.
I was just thinking, actually, and this could be a question for Dr. Decker too, because I was just thinking, I feel like we've had this conversation before about how spatial, depending on the pattern configuration or spatial pattern, can present its own risk to the forecast. If those cool Morm anomalies are close to important population areas, where just a subtle, a small change, relatively speaking, in terms of the pattern configuration could lead to a non-trivial change in HDD or CDD, right? So the forecast errors by a spatial 500 millibar height kind of count could end up being small, and yet your HDD and CDD could be big. I was thinking about this with Dr. Decker started presenting his forecast, and then again with Dr. Roundy, like, oh shoot, should my spread be higher because, if that cold anomaly it catches a little bit more of the I-95 corridor, it could be a lot cooler, and vice versa. if it's a little bit further back toward the middle part of the country, Nebraska, where no one lives, it could be a lot hotter. I don't know. Does anyone else have any concerns or thoughts on that? Maybe I'm making too much of it.
I think it makes sense. That's that's basically how I come up with my. I usually keep my sigma forecast pretty close to the climatology, but when I do see these gradients near highly populated areas, I'll tend to bump it up. Or if it's like the country is red, I bump it down a little bit. But yeah, this is definitely one of those forecast maps where I decided to bump it up some.
Actually, I had a question about that, Dave. Is there a way we can see how the population is weighted for this as to like what region, how close it has to be in order for it to make such a large influence like that?
Yeah, that's a good question. Let's see. So probably, like we could probably ask Maxar to get a little bit more information on that. Who knows? Maybe it's even available somewhere on the site. But I think if you wanted to get a proxy, if you just Googled a population weighted kind of thing, map of the United States, you would have a pretty good. If you're looking for something like qualitative, you would get a pretty good impression, right? You would get a pretty good estimate, like Northeast megalopolis, huge concentration, big population, big weighting, out towards Chicago, and just the eastern sort of I always say like the Chicago, New York, Atlanta corridor is a huge thing. Even back to Dallas, and then a lot of the interior West, there's not too much, and then you get some in California. So that obviously I'm giving you very loose, but again, I would, if you want a little bit of it better, I would just kind of look at a population weighted map or something like that online. But we could try to ask Maxar to see if they have something, because technically we're looking at gas weightings. Gas weightings are a little bit different than population weightings, but my experience, they're not going to be that different, So yeah, that's a general idea though.
I've looked at some of those maps, and like for example, it'll break down like New York, Pennsylvania, New Jersey, and put them all together. Whereas like the population area is just a small portion of that physical area. So is it averaging the temperature, like taking in upstate New York with New York City, and then giving it the same population weight? Or I was just curious as to how that part works.
Yeah, it's a good question. There's different, and again, I think I'll start off by saying that Maxar can probably, it's somewhat proprietary, but I'm sure they give you, some better explanation I'm going to give you. But I think groups do it. Every group probably does a little bit differently. But I know one of the processes that's been fairly common is to use climate division. So, there's, if you've ever seen a climate division map of the United States, I forget how many are. Is it 250 or something like that? But or maybe it's 350. Well, so these small little climate divisions that make up, the country. So the states divided into numerous climate divisions, and then and that's determined by, I think, NOAA or NCDC. NCDC came up with something like that. So what groups will do is they'll create the population weighted or HDD climate divisions. So, and they'll base that on some sort of you'll start with you have stations. You have to start with a minimum number of stations. Again, every group might determine, might have a different minimum. Some might go as low as 20 or 50 even. A lot of groups, I think, have hundreds, maybe even some have thousands of stations if they're really sophisticated. So they'll start with the stations. Then they'll have some sort of an interpolation process in order to derive the climate division, temperature, and population weighting or HDD weighting. And then from that climate division level, they'll scale it up. So the climate divisions are within a state. So then they'll scale up those climate divisions to have a state sort of CDD or state HDD. And then, as you, I think, alluded to, you also look at regions. So they'll have, it's very important, like they have these, what they call like these energy regions, EIA regions. And so it might be like 10 states in the north, in the West, make up a certain region. So then they'll scale up those 10 states. Originally, starting from the station level, you derive the climate division data, climate division to state, state to region, and even, all the way up to the national level, which is what we use, the CDDs and HDDs. So there's a number of steps, right? I'm kind of glossing over. There's a number of steps, but ultimately it starts from having a certain number of stations and hopefully, clean data, good, reliable data, having the population or gas weightings, and you get that information from different sources, and then having some sort of process, interpolation process, scaling process, where you can kind of put those data sets together.
Okay.
So I have a density map up on my screen that I can share. If
yeah, go for it.
So
there you go. Yeah.
Here's the density map. And the way I think of it, I'm not trying to think of every single dot on this map, but I sort of think of in terms of clusters, right? You have the Northeast corridor, you have this sort of lower Great Lakes region, maybe including Minneapolis. You've got this sort of Atlanta to Charlotte area, and you've got the Florida Peninsula, Texas, East Texas, and then California are sort of the areas that when I'm thinking is there a populated area that could swing things. Those are the sort of the clusters of areas, or the larger areas I'm thinking of. Yes, there's Denver and Salt Lake City and Kansas City, but they're sort of isolated more. So I'm not going to pay as much attention to some sort of gradient here in Colorado, but certainly some of these other areas, I definitely will.
Okay. Yeah, I was just curious as to how much it matters where the gradient lies, if it's like prior to the city or one of those densely populated dots, or if they're just averaging it over a region. So if the gradient is in the middle of it, it doesn't really make much of a difference because it's just an average.
Yeah, I don't remember. I know it's like 50 population areas are included, but I don't know, is it like one station to represent the whole area, or if they're doing an average over that area? Like for instance, for the New York City area, are they just using Central Park, or are they using Newark and LaGuardia and JFK and Trenton, and averaging all this together to come up with the population weighted CDDs and HDDs? That I don't know.
I think with Maxar, I think it's very likely they're using just more than Central Park. I think they're using Newark and stuff like that. But yeah, every group is going to be a little different. And as memory serves, once you get up to, again, this is some loose math. Don't reproduce this. But like, I think once you start getting up to about 50 or 60 stations, the correlation starts to get pretty good. In other words, you can get some fine tuning and improvement. But once you have the top 50 or 60 stations, or population areas of the country, the biggest, then your level of improvement does start to plateau, right? Because you've got the 95% of the population, and then you're sort of adding the trends, which gives you a little bit of nuance. But and it's more important, that nuance is really important when you're starting to get down to the regional and sub-regional level, right? So, and there are, if we're talking about trading, there's definitely groups that are trading on smaller levels. Power traders are trading, the southern New Jersey versus northern New Jersey. And certainly when you start to get down to that level, you're definitely going to want to have those, a higher density of stations. Okay, well, I'm just looking at this time. Let's try to get in maybe at least one other student here. Well, Sean, you produced the forecast, right? Did. How about we put you on the hook here? And why don't we get, I don't know if we'll have Nat Johnson, I don't know if we're going to have time for Nat to do his forecast, but how about you present your forecast to Nat, and Nat can use his research hat, his Dr. Johnson hat, and respond to your forecast.
Okay. So,
a lot of rain.
Yeah, that's just from the storms coming through.
Yeah.
Yeah, so I actually use that as part, not so much the most recent storms that are happening right now, but the frequency of the storms leaves me to not be very confident in forecasting the entire East Coast and Gulf region. There could be a lot of variability in there, but I went a lot of the CPC, and then I used the 10-year as kind of a baseline. And similar to the CPC, I looked up the EC, the MJ or JMA, and I used SubX to show the pattern. And they all came up with a very similar pattern. So I kind of stuck with that. And considering the population density along the East Coast, I couldn't tell if this was actually going to end up being cooler. Like I said, with all the tropical storms coming through, there's a strong possibility of that. But everything, all the consensus pretty much had the whole Southwest as above average. And looking at the soil moisture for that region is still very low, below average and in a drought. So I use that as verification that it would continue to stay as above average temperatures according to the EC. But that was kind of just a quick run through, trying to keep it a little bit different than what everybody else has said. But I've been playing with the SubX for a little bit. The past few weeks, I've been incorporating it into my forecasts, and we'll see how it works. But
did you mention what your forecast is?
Oh, I'm sorry. I did. $37.4 with a spread of 7.5. I'm not very confident in it, so I gave it a slightly higher spread. Like I said, there could be a lot of variability, especially on the East Coast.
Okay, but a lot of consistency on the West. So Western, warmth, and
Yes.
basically all the dynamical models, right?
Yeah, pretty much. Yeah, the whole West, Southwest is warmer. Central, just a little bit north of Texas into Mississippi and all the way through to Chicago is cooler. But then when it hits the East Coast, I wasn't very confident in above or below average.
And so it is forecast to be very active with tropical cyclones over the next few weeks. So, so how exactly does that impact your forecast?
So I take it as a source of cooling. If the tropical cyclones are near landfall or make landfall, especially as they move their way up the East Coast, I interpret that as a source of cooling, and considering the frequency of them, it's probable that one will happen in this 5-day period, or at least be present during this 5-day period. I don't know if that's a correct correlation to make, although the sea surface temperatures are above average around Florida and some of the New York area. I still feel that the tropical storms will give way to some cooling.
Okay. And I haven't followed the SubX or JMA this year. Do you have any comment on how they've been performing this summer?
JMA has been pretty good. SubX, not very consistent. For June and July, it was a little bit more consistent. August has not been that great, but everything was pretty persistent, and it bases a lot off of the EC. So since the SubX uses the EC, and the EC was doing very well for June and July, by translation, the SubX was doing well. I don't know what the percentage is for how much they give to each model, but even the JMA for this period, or for the 30-day period that they give, has a similar cold region. But I haven't looked through previous year data on the sub-X.
I think that that cool region would be there even if the storms didn't occur, but having the higher evaporation rates after the storms have passed would kind of act to persist it.
Agreed.
All right, thank you very much.
Thank you.
You know, I know we're out of time, and I apologize to a couple of folks who aren't going to get a chance to do the forecast, but just a couple of thoughts there. One, yeah, I can't believe that hurricanes hadn't come up before that. So, Sean, thanks for bringing that up. And yeah, because you know, that's definitely a topic, in particular in industries, how hurricanes might influence this forecast. And so I wish we had more time to discuss that. But and the other thing was just with the sub-X, I think it's really interesting you brought that up. And I think it's always important. I think you did a pretty good job on this, but just, remember, right, you know, if Nat is your client, you know, and it's great to be using a different forecast, but always make sure you can justify it, right? Like, why are you using it? I think that's sort of the question that Nat was getting at. Why are you using this instead of the EC and CFS? I'm sure, you know, make sure you have a good reason, right? Obviously, you're not going to, you know, you're not making a forecast off of a model just for the sake of it, right? You're using it either because, you know, you are literally going through some just sort of experiment in a research mode, and that's one thing, right? Or B, it's because, you know, for whatever reasons, you think this is going to provide you value that you're not going to get from those models, right? And you just want to make sure that that's clear to your client. Like, hey, I've looked at the verifications, I've done this, I've done that. I feel confident that this is better than EC or CFS, or something like that. Is that fair, Sean? Okay. Yeah. So thanks for everyone for joining in today. I thought it was a really good discussion, and I think next week, I think our scheduled time is again on Tuesday. So look forward to hopefully seeing some of you guys there again next Tuesday.
Yeah.
All right. Take care, guys.
Thanks, you too.
too.
Thank you.
Thanks.
Thank you.
Bye, guys.
Bye.